Hey everyone, it's Justin again. Our lesson today is a review of polynomial long division. We've done this earlier in the course, so if you'd like another resource after watching this video, definitely go back to our previous polynomial long division lesson. Today, we're going to get a refresher on this topic so we can use it later in this unit. By the end of this lesson, you should be able to divide polynomials using long division. First, we'll compare division with regular numbers to division with polynomials. Next, we'll complete an example and develop steps to help us remember the process. Then we'll complete one additional example using the steps we've created. Let's start today by talking about division with regular numbers versus with polynomials. Long division is a great way to divide two numbers. For example, we could factor out 5 and cancel it from both the numerator and the denominator, or we could write long division like this. Fairly simple, right? And what about this? Since we have the problem before to compare it to, we can see that it's almost the same answer, just 2/5 more. Or maybe you would prefer long division here. Maybe you did this in your head and are wondering what my point is. Well, I want you to understand that polynomials just represent numbers, so they have the same properties. Look at this polynomial. We can cancel factors and get our answer just like we did with 40 divided by 5. We wouldn't need long division here because factors cancel, just like we didn't really need long division to find 40 divided by 5. And if we have this problem to compare it to, then this problem isn't too bad either. The numerator would just be 2 less than the problem we just did and give us a remainder. But if we took this problem away and say I never showed it to you in the first place, would you still be able to find this answer the same way? I probably wouldn't. This is why we can use long division. Long division for polynomials is just like long division with regular numbers. Let's explore this more by using polynomial long division to simplify this expression. We look at the numerator here and notice right away that 2x squared minus 5 would be a mess to factor. That's why long division is a better strategy here. So we set up our long division symbol, then we put our dividend inside the symbol. Notice that we don't have an x term, so we're just going to put 0x as a placeholder here. Then we move on to the divisor, and that goes next to our long division symbol. We're going to develop some steps here to help us remember how to do polynomial long division. So let's call what we just did step 1, set up the long division. Now that it's set up, we have to divide to see what goes on top of our division symbol. So we take the first term here, which is 2x squared, and divide it by the first term here, which is x. 2x squared divided by x is just 2x. We're going to put this up top above the other x term in our dividend. This completes our second step. We'll say this step was to divide the first terms. All right, let's move on to step 3. What do you think we should do for step 3? What would you do at this point if you were just working with regular numbers? We would have to figure out what to write underneath. We'll call step 3 multiply to write underneath. So we have to multiply what we wrote in the top by the divisor. 2x times x gives us 2x squared, and 2x times 3 gives us 6x. Then, for step 4, just like you would with regular numbers, we subtract what we wrote underneath. So let's subtract. 2x squared minus 2x squared is nothing, so this cancels, but 0x minus 6x is negative 6x. Great, step 4 is done. Now, what would you normally do next if you were dividing regular numbers? Hopefully, you thought of bringing down the next number and doing this whole process over again. We can call this step 5, which says to bring down and repeat steps 2 through 4. Let's do that now. So bring down the minus 5. Then repeat steps 2 through 4, which were divide, multiply, and subtract. Okay, here we go. Divide negative 6x by x. This will give us negative 6. Multiply negative 6 times the divisor and write what you get below. Then subtract. We have to be super careful here not to mess up a sign. So let's take this slow. Negative 6x minus negative 6x would be the same as negative 6x plus 6x, which cancels. Negative 5 minus negative 18 is the same as negative 5 plus positive 18. This equals 13. Since we didn't end up with 0 here, we have a remainder of 13. For our final answer, we just have to write what we got on top of our long division symbol and our remainder over our divisor. And this gives us our final answer. All right. So I want you to think about your comfort level with polynomial long division after seeing this example. The goal right now is to become confident enough to do this all by yourself. So, was this an easy review for you? If not, I want you to take a little time out here and go back to the MIA website. Then search for the polynomial long division lesson from earlier in the course. Watch some of that video to get more examples. So pause this video and do that now, then come back to finish this video. Welcome back. Here's our final example for this review, and after all that reviewing, I want you to be able to do this correctly all by yourself. So here are the steps again, just in case you need to add them to your notes. Pause the video now and do this long division problem all on your own. All right, let's see how it went. We're going to go through the entire process once more. So if you got stuck anywhere when you were working on this problem, pause the video after you get clarification and keep working through it on your own. First, let's set up the long division. We start with the long division symbol. Then we put our dividend inside the symbol. Notice that we do not have an x squared term, so we put 0x squared as a placeholder. Then we put the divisor next to the long division symbol. Now that it's all set up, we have to divide to see what goes on the top of our long division symbol. So we take the first term here, 2x cubed, and divide it by the first term here, 2x squared. 2x cubed divided by 2x squared is just x. We put this up top above the x term in our dividend. Then multiply back through. Multiplying x by all three of these terms gives us 2x cubed plus 6x squared plus x. Then we subtract. 2x cubed minus 2x cubed cancels out. But 0x squared minus 6x squared is negative 6x squared. And 4x minus x is 3x. Then bring down the next term and do all these steps over again. Divide negative 6x squared by 2x squared. This will give us negative 3. Multiply negative 3 times the divisor and write what you get below. Then subtract. As usual, the first term here cancels. 3x minus negative 18x equals 21x. And 9 minus negative 3 is 12. Since we didn't end up with 0 here, we have a remainder of 21x plus 12. For our final answer, we write what we got on top of our long division symbol, and we write our remainder over our divisor. That will give us our final answer. Whew. I bet you're wondering why we needed to review polynomial long division anyways. Well, in the rest of this unit, we're going to learn how to graph functions like this. Spoiler alert, you know those asymptotes you've been learning about? Well, they're going to get really interesting in the next few lessons, and polynomial long division will come to the rescue. See you then!
Hey, hey.